Due to extensive usage of natural resources, disasters like flood, forest fire, earthquake, landslide, etc. are the major reason for human deaths. It can be extremely dangerous to send the first responder to the spot. The UAVs are very much useful to help in recovery after disaster, but most require individual pilots to control it. Greater the delay, greater is the distress due to lack of one or more of relief suppliers and can delay actual aid from reaching victims. The drones have lower backup compared to gliders, and gliders doesn't have an option to hold in certain altitude. In order to design a UAV with larger backup, like RC flight and high stability like drone, we have to incorporate the flight and drone technology to create a hybrid UAV. As we know, the nature is basic key factor for technology evolution. As William Shakespeare said, "It is quite true, nature is the best teacher." Everything in nature is grand and flawlessly perfect. As we look up to the nature, we got an idea to incorporate a dragonfly's anatomy into our UAV. Let's have a look into it. Dragonfly has an ability to move in all directions and have a high stability when compared to other creatures. Similarly, our UAV can fly in all directions: forward, reverse, upward, downward, side-to-side movement, with a pair of motor-driven propellers and 2 pair of wings. To achieve the stability of UAV, gimbal in the base is adopted. Dragonfly have the most amazing vision in Ultra HD in 360 degree. This keen visibility is from a pair of big compound eyes consisting of several thousands of individual lenses. Similarly, in our UAV we have 2 cameras, a digital camera for surveillance and a thermal imaging camera for sensing the hotspot. Dragonfly can fly at a speed of 97 km per hour. Our UAV can fly up to 150 km per hour.
This is the enlarged scaling of real Dragonfly, the God's Eye model, which has 2 BLDC motor-driven propellers in the forewings producing thrust for UAV, and the servo-based 11 mechanism in the hindwing for pitch and roll control. It is a hybrid model. It has both vertical takeoff and vertical landing VTVL like drone and conventional takeoff and landing CTOL like flight and gliders. Both pair of wings can be rotatable with the help of servos. During takeoff and landing, all the wings are in vertical to move upward and downward direction like drones, and the wings are rotated to 90 degree, that is horizontal, the vehicle in flight mode. In the head we should have a digital camera on one eye and a thermal imaging camera on the other eye. The gimbal, battery and LiDAR should be in the bottom of the UAV for stability. For better stability and balancing the UAV, the tail may have rudder and elevator control. A comparative statistics is shown between the drone, flight and our God's Eye model for the reference, as our design adds more value than the current available design and solutions. The gap between the existing solution has been filled by God's Eye model. As God's Eye is a hybrid UAV, which has the advantages of drone stability and enhanced gliding time, which helps in power optimization. Hence, we conclude that, by implementing the God's Eye UAV, we can achieve the attitude stability with more gliding time. The automatic surveillance, identifying the disaster area, and intimate to the rescue team, with hotspot imaging, are the major roles of God's Eye.